An arc subtends angle 50 degrees at the center of circle of radius 6 cm. Calculate the area of the sector formed. A. 80/7 centimeter square. B. 90/7 centimeter square. C. 10/7 centimeter square. And D. 110/7 centimeter square. In this question, what is required is to calculate the area of a sector. So we are going straight to apply the formula. Area of a sector is given by the general formula theta over 360 times pi r square, where r is the radius and theta is the angle given. So given that theta is 50 degrees and radius is 6 centimeter, and pi is given as 22/7. So we are going to substitute this into the parameters. We have area of a sector is equal to theta is 50 over 360 times pi is 22/7 times radius is 6 square. Area of a sector A is equal to 50 times 22 times 6 square is 36, all divided by 360 times 7. Okay, at this point we can make it very simple. 0 goes into 0 and 36 goes into 36. Okay, so we are left with 5 times 22, and 5 times 22 is 110 divided by 7 in centimeter square. So this is the final result, and the correct option on the board is option D. A cylindrical pipe 50 centimeters long with radius 7 centimeters has one end open. What is the total surface area of the pipe? Option A, 749 pi meter square. B, 700 pi meter square. C, 350 pi meter square. And D, 98 pi meter square. We are going to apply the general formula for total surface area of a cylinder. So when we are referring to pipe, we are actually talking about the curved surface area, one circular end. So total surface area equals curved surface area plus one circular end. Okay, the general formula for this, for total surface area of a cylinder, is given as curved surface area 2 pi r(h) plus pi r square. So at this point, pi is given as 22/7, whereas the radius is given and the height is also given. So from the question, the circular pipe 50 centimeters long, the height h is equal to 50 cm with radius 7 centimeters. So radius r is equal to 7 cm, and pi is given as 22/7. But at this point, we are not going to make use of the value of the pi because the question was expressed in terms of pi. So let us substitute into the formula. Total surface area is equal to 2 pi r squared, which is 2 times pi times r. R is 7 times height is 50 plus pi times r is 7 times 7, which is 7 squared. So this gives 2 times 7 or 2 times 50 gives 100, and 100 times 7 gives 700 pi plus 7 times 7 gives 49 pi. So 700 pi plus 49 pi gives 749 pi. So the correct answer for the total surface area of the cylinder or of the pipe on the board is 749 pi in meter squared. So that is the correct option. Option A. Now note this, the distance between 2 points in a coordinate system is given by this general formula. The distance is given by the square root of, in bracket, x2 minus x1 all squared plus y2 minus y1 all squared. So this is the general formula for the distance between 2 points in a coordinate system. Now in a coordinate system, to locate a point, we always have, in a point, let's say point P, at this point P, to get the coordinate system in parentheses, it is always x before y. So it is x before y. So if you are comparing this to the 2 points or 2 positions on the question, that is to say the first value written is for x, whereas this person is for y. So we have in the formula, distance d is equal to square root of in bracket x2, and x2 we have minus 1 over 2, then minus 1 over 2 all squared plus y2 is this. Okay, let me label this. This is x2 and this is x1. So this is y2 and this is, this is y1. So we have x1, y1, x2, y2. So at this point, we are working on the y2 minus y1. So y2 on the board is minus 1 over 2 minus y1 is 1 over 2 all squared. So this gives minus 1 over 2 minus 1 over 2 gives minus 1 squared plus the same thing here, minus 1 squared. So we are going to obtain minus 1 squared is plus 1. So we have 1 plus minus 1 squared is 1. Therefore, we are going to obtain square root of 2, which is an irrational number. So the correct answer on the board is option B, root 2. From the gradient of the line passing through the points P, 1 and 1, and Q, 2 and 5. Option A, 5, B, 4, C, 3, and D, 2. To determine the gradient of a line passing through these 2 points on the board, we use the general formula gradient small letter n is equal to dy, change in y rather, all over change in s. So change in y is y2 minus y1 all over x2 minus x1. In a coordinate system, points are represented as point P. Point P is represented as x and y coordinates. X before y. That is to say, the first number written is always the number representing x, whereas the second number written in the bracket is always the number that is representing that of y. At P, we have x1 and y1. Then at Q, we have 2 and 5, which is x2 and y2. So we can substitute this into the equation. In the equation, gradient m is equal to change in y, y2 minus y1, and y2 is 5, 5 minus y1 is 1, all divided by x2 is 2, and x1 is 1. So at this point, we are going to obtain 5 minus 1 is 4, and 4, and the correct option is 4. So the right option on the board is option B, 4, which is the gradient of the line. The question says, if y is equal to x sine x, find the y over the x. The options are given below. In the question on the board, y is a function of x sine x. So y is the function of x sine x. We can also express this function as x times sine x. So this means that y is a function of the product x and sine x. In differential calculus, to determine this function or to find the derivation, we apply the product rule. In differential calculus, the y over the x is equal to u dv over dx plus v du over dx. Now on the board, since y is the function of this, we can say that let the first term x, let u equal to x and v equal to the next product sine x. Okay. So from the formula, we have to determine the v over the x. That is the derivation of v with respect to x, and also the derivation of u with respect to x. So to find the v over the x, we have to find the derivation of v. So the derivation of v with respect to x is what we call dv over dx. Whereas the derivation of u with respect to x is what we call du over dx. So from here, dv over dx, which is the derivation of v with respect to x, is equal to sine x gives cos x. The derivation of sine x is equal to cos x. So we have cos x, and du over the x, which is the derivation of u with respect to x, is equal to, if you find the derivation of x, we are going to have 1. So we can substitute this into the formula. dy over the x, is equal to u times dv over the x, and u is x, so it will be x times dv over the x, and dv over the x is cos x, then plus v, and v is given as sine x. V is given as this point, the y over the x is equal to x cos x plus sin x. So that is the final answer, x cos x plus sin x, or we can still say as sin x plus x cos x. Let's go back to the option. The correct answer is sin x plus x cos x. The order of the arrangement does not have any bearing. So the correct answer is D. At what value of x does the function y equal to minus 3 minus 2 plus x squared attain a maximum value? In a differential calculus, to obtain the maximum value, we must find the derivation of the function given, then set the function to 0. That is to say, the y over the x must be equivalent to 0 before maximum value can be attained. So, in this question on the board, the function given is y is equal to minus 3 minus 2x plus x raised to the power of 2. So first thing first is to find the derivation of y with respect to x, or otherwise it is known as dy over dx, or f at x. Now to do so, let us apply this principle. The principle is that if y is a function of x, n. Now the principle is that if y is a function of x, then the derivation of y, which is dy over dx, is going to be given as n x raised to the power of n minus 1. We are going to apply this principle to obtain the derivation of the respective terms on the board. Now, since the function is given as this, applying this rule, dy over dx is equal to the derivation of a constant term is 0 plus the derivation of minus 2x is going to give, this is minus, is going to give 2 plus the derivation of x squared using this principle is going to give 2x. So dy over dx is equal to minus 2 plus 2x. Now at maximum point, dy over dx is equal to 0. So dy at maximum point, dy over dx is equal to 0. So that is to say, we are going to equate this result to 0. So in this place, we have minus 2 plus 2x is equal to 0, making x the subject of the relation or the subject. So we have 2x is equal to, when minus 2 crosses over the equality sign, changes to plus 2. Then plus 0. So we have 2x is equal to 2. Making x the subject, divide both sides by the coefficient of x, which is 2. 2 here, 2 cancels 2, and we are left with x is equal to 2 divided by 2. Therefore, x is equal to 1. So at maximum point, or the maximum value of x in this question is plus 1. And the correct option on the board is option B. Evaluate x cubed plus x squared dx. The upper limit is 2, while the lower limit is 0. Option A, 1 whole number 5 over 6. B, 2 whole number 5 over 6. C, 4 whole number 5 over 6. And D, 6 whole number 2 over 3. This is upper and lower limit in integration. To do this, we have to find the derivation, or we have to integrate the bracket first. Then before applying the method or the rules for upper and lower limit. Okay, so in the bracket we have x cubed plus x squared dx. Now in integration, if y is a function of x, let's say y is equal to x raised to the power of 10. To find the derivation of y with respect to x, or to find the y over the x, or f at x, we can say that dy over the x, or f at x, is equal to x raised to the power of n plus 1, all divided by n plus 1. So we are going to apply these principles to derive the respective terms on the board. So to do so, it becomes x raised to the power of 3 plus 1, all divided by 3 plus 1, plus x raised to the power of 2 plus 1, all divided by 2 plus 1. This is the first thing we must obtain. Now, since the upper limit is 2 and the lower limit is 0, so we are going to put 2 here, 0 over here. This gives x raised to the power of 4 all over 4 plus x raised to the power of 3 all over 3. The upper limit is 2 and the lower limit is 0. So the next thing to do is to provide two different brackets. The difference between two different to this. Now, that becomes the first bracket minus another bracket, second bracket. So first bracket minus second bracket, that is what we do in upper and lower limit. So this thing is very simple. In the first bracket, we are going to replace the upper limit, which is 2, with x. Any place where x is rating from here, we are going to replace the x with 2. Whereas in the second bracket, we are going to replace the value of x with 0. So this is very simple. Now in the first bracket, note, the first bracket is basically for the upper limit, which is 2. Anyway, where x is rating, I will put 2 there. So that is to say, x raised to the power of 4, it becomes, in bracket, 2 raised to the power of 4 all over 4 plus x raised to the power of 3, in bracket, 2 raised to the power of 3 all over 3. Then, in the second bracket, instead of writing 2, it will be 0. So that will be x raised to the power of 4, which is 0 raised to the power of 4 over 4 plus 0 raised to the power of 3 over 3. That is the basic principle in upper and lower limits. Okay, let's continue from here. From the first bracket, 2 raised to the power of 4 is something as 2 times 2 times 2 times 2. And that will give 16 over 4 plus 2 raised to the power of 3. 2 times 2 times 2, which is 8 over 3. Minus, now in the second bracket, we have 0 raised to the power of 4. And 0 raised to the power of 4 gives 0. 0 divided by 4 is 0. Plus 0 raised to the power of 3 is 0. And 0 divided by 3 is 0. So everything in the second bracket gives 0. So the second bracket is 0. So we are left with this. 16 divided by 4 gives 4 plus 8 over 3. Since the denominator is 1 here and the LCM is 3, we can simply use the shorter method by cross multiplication. So if you cross and multiply, we have 12 plus 8 all divided by 3. This is the simplest method. We can actually look for the LCM. So this gives this plus this gives 20 over 3. So the answer is 20 over 3, but in the options, we are given in whole number. So we can actually change this bigger fraction to a whole number. Now 3 goes into 20 how many times? 6 times, it will remain 2 all over 3. So the correct answer is 6 whole number 2 over 3, and the correct option is 2 over 3.